So, like I said, this file is showing you the difference between exponential functions and logarithmic functions. These two functions are literally the inverses of one another. They're opposites. Okay? Examples of exponential functions you see are like f of x is equal to 4 to the power of x, or something like g of x is equal to 1/3 to the power of x. These are those graphs that we looked at a couple days ago in 6.1, where you looked at a growth or a decay. If you have something like the f of x, where your base is greater than 1, you have a growth. So you know that that line is going to go up from left to right. When you're looking at something where your base is less than 1 but greater than 0, we have a decay. So that line goes down from left to right. And again, there is a decay. Okay. When you're looking at these, you're going to have to identify the domain, the range, your y-intercept, and your horizontal asymptote. If you remember, when we worked with horizontal asymptotes in chapter 3, you took your denominator, or no, sorry, you took your powers, like you looked at your powers of both the top fraction and the bottom fraction. So we found those a little differently. You're not going to be able to do that in these. With these, you're going to take that vertical shift. So if you remember, way back in the beginning of the year, we went over transformations. Those vertical shifts are those up and down shifts. So that plus a number, minus number at the very end of your expression for your function rule, that's not inside parentheses. Okay, so those you're going to have to keep that in mind with your, like I said, your transformations from the beginning of the year. Y-intercept, easy, plug in 0 for x, solve for y. It's the ordered pair, 0, something. Always, your domain is going to be from negative infinity to positive infinity, so all real numbers. Your range is based on the plus or minus that's in front and your asymptote. Remember, your asymptote is that invisible line that y is equal to a number that's showing you that your line that's drawn on your coordinate plane does not cross over a certain y value. Okay? So literally, your range for these are literally going to be from negative infinity up to a number with parentheses on both, or that number to infinity with parentheses on both. Okay? You're going to take the vertical shift number that you see with those, and that's going to give you whether or not you're going, or that's going to give you your number within your interval notation. Okay, so like, for example, for number 1, if we're working with an exponential function, we have f of x is equal to negative 2 to the power of x plus 7. That negative means that it flips. So this negative here flips your line. So normally it would look like this. So that would actually flip it to look like this. From there, I'm sorry, this would, that's like opposite of what, no, that is right, I'm sorry, that is right. Okay, no, it's outside, so it flips vertically, yes, okay, so that is exactly what it looks like, this one. Okay, so from there, you want to think of that as, where is your range going to be from? Is it going from a number to positive infinity, or is it going from negative infinity up to a number? This is going from negative infinity up to a number, so your range is going to start at that negative infinity. You get that other number by your vertical shift. In that case, your vertical shift is coming from this 7. This means that it goes up 7 units, so it goes to 7 and down for your range. We know automatically, we said the domain is going to be all real numbers, so that's from negative infinity to positive infinity. We did our range. Your horizontal asymptote is y is equal to your vertical shift. What was the number that we put into your range? The 7, so that's just y is equal to 7. And lastly, to find your y-intercept with these, easy. Take the expression that's given to you, change the f of x to be y is equal to, then plug in 0 for x, and solve. So that's going to be the opposite of 2 to the power of 0 plus 7. The 2 to the power of 0 is 1, so that's y is equal to negative 1 plus 7, which is 6. So the ordered pair, that is your y-intercept, is 0, 6. So the other type of function that we have is your logarithmic function. Your logarithmic function is literally the inverse of your exponential function. So instead of these graphs looking like your growth and decay like you see on the left, the far left, on the right you have examples of those logarithmic functions with g of x is equal to log 10 of x minus 1 and g of x is equal to ln of 2x minus 3. If you look on your calculator, that ln is where you're getting that e to the power of button. So some of these you'll also see as e to the power of functions. They look the same way. Or sorry, they're inverses of one another. So it's the same exact concept with these. So that e to the power of x is your exponential. Your logarithmic form is that ln. Okay. For these, you see that they look kind of, I was going to say kind of like an upside down L. Okay. It all depends on, with these, with your domain. So your domain in your exponential is all real numbers. If these are inverses of one another, that becomes your range of your log functions. So your range for these is going to be your automatic all real numbers from negative infinity to positive infinity. Your domain is based upon your vertical asymptote. To find your vertical asymptote, you're going to set whatever is in parentheses, whether it's a log function or that ln function, they're still log functions, equal to 0 and solve. Okay? So if we look at number 4, you have g of x is equal to log 7 of 2x minus 3. We said automatically, right off the bat, your range is going to be from negative infinity to positive infinity. Next, you should ask yourself, do I have anything in parentheses? You have the 2x minus 3 in parentheses. So set that 2x minus 3 equal to 0 and then solve. To solve this, we're going to first move over that 3, so we're going to add it to both sides. We get 2x is equal to 3. Then we divide each side by the 2 and get that x is 3 over 2. So that x is equal to 3 over 2 is your vertical asymptote. To find your domain, look at the way your function would look. So if you look at the graphs up top, your graph would look like this. So your domain is going to positive infinity. Your lowest value is going to be whatever your x is equal to in your vertical asymptote. So that's going to be from 3 over 2 to positive infinity. Think about your transformations. If you're looking at reflections, specifically with your log functions, automatically, if it's positive, it's going to be opening to the right. So it's going to go to positive infinity for your domain. If it reflects across the y-axis, so it reflects across y, that means horizontal reflection. That negative would be on the inside of your parentheses. Then that means that it would go to negative infinity first for your domain.
If the base of the x is positive or negative, that's what determines it?
If the number, the first number inside the parentheses is negative, that's what depends on whether or not it goes to the left or right. Okay?
So if it was a negative 2, it would be negative infinity 3 half.
So if it was a negative 2, you would think about it as like, here, let's look at this. If, let me do this in a different color so that way you can see the difference between it. Okay, so if it was, let's say, f of x is equal to log 7 of negative 2x minus 3, you got to think of this as if it was the opposite of 2x plus 3. So then, yes, you would have a reflection horizontally across your y-axis, which means that that log function would then open to the right, or sorry, to the left, and go to negative infinity first for your domain. Okay. All right, let's look back at your exponential functions. We said with exponential functions, your domain is automatically all real numbers, so from negative infinity to positive infinity. Your range is found by taking your horizontal asymptote, so that vertical shift, so the number that's by itself at the very end, either plus or minus. From there, your y-intercept, plug in 0 for x, solve for y, give the ordered pair 0 comma something. Okay, so for number 2, you have f of x is equal to 5 times 1/3 to the power of x plus 1 minus 6. Just kind of think about the way the line would look. Normally, for an exponential function, it would look like this, or it would look like this. It depends on the base. In this case, the base is 1/3. It's less than 1 but greater than 0, so your line is going to look like this one. Okay, so I'm going to erase this. Oops, erase that. Your line looks like this. Okay. Automatically, your domain is what? All real numbers. So from negative infinity to positive infinity. What is your vertical shift? What's the number at the very end by itself? -6. So that means that your horizontal asymptote is also y is equal to -6. Use that with your range. Your range is going up or down? Up. So it goes to positive infinity. So the lowest number you're going to have is that vertical shift. So from -6 to positive infinity. Lastly, find your y-intercept. Plug in 0 for x, solve for y, give the ordered pair 0 comma something. So if we rewrite this as y is equal to 5 times 1/3 to the power of 0 plus 1 minus 6, this is going to give us 5 times 1/3 to the power of 1 minus 6. 1/3 to the power of 1 is just 1/3. So 5 times 1/3 minus 6. That's 5/3 minus 6. Remember to subtract numbers where you have a fraction as 1 and the whole number as another. You got to turn that whole number into a fraction, which is 6/1. Then find the least common denominator and rewrite it with your denominator. So that's going to be 5/3 minus 18/3. This gives us -13/3. So the ordered pair that is your y-intercept is the ordered pair 0 comma -13/3. For 5, you have g of x is equal to -ln of x plus 6. You're finding the domain, the range, the vertical asymptote. We know, because it's a log function, it's the inverse of the exponential function, which means instead of our domain being all real numbers, our range is going to be all real numbers. So off the bat, you can put down that your range is from negative infinity to positive infinity. From there, use the vertical asymptote, or solve for the vertical asymptote. Your vertical asymptote you're getting from the set of parentheses. You have the x plus 6 in the parentheses, so set that equal to 0 and solve. So x plus 6 is equal to 0. Subtract your 6 over. That gives you x is equal to -6. That is your vertical asymptote. If x is equal to -6 for your vertical asymptote, your domain is going to include that -6. You just now have to figure out on whether or not it's going to positive infinity or if it's coming from negative infinity. If you look back at the very top of this, it tells you that a log function normally looks like this. The negative that's in front of the ln represents what? A reflection. How? Vertically, horizontally? It would be vertically. It's not in parentheses, so it would happen vertically, which means it would reflect across your x-axis. So this graph would look like this. So think about that. Your domain, it goes from what to what? The lowest possible would have to be, not negative infinity. This goes to the right and up.
No, -6.
So the -6 is going to be your lowest number.
Right.
And then your highest number is going to be positive infinity. What's wrong?
The negative in front of the ln, or the ln, I'm not sure but the negative in front of the equation, it doesn't apply to the x plus 6, so it would be positive, right?
Correct.
Okay.
Yeah. So that negative that's in front of that ln literally just takes it from the pink line to the green line.
It's the same.
So it literally just flips it vertically.
Same difference, then, basically,
Mhm.
in terms of the domain. Okay.
Yep, that's why I was saying you have to try to think back to the beginning of the year with your transformations. And remember that the negative in front of the parentheses is vertical. So it's reflecting vertically. The negative inside the parentheses is reflecting horizontally. So you got to think about that.
What would it mean if the negative was outside of the parentheses but in front of the
It wouldn't.
parentheses? It wouldn't be.
It wouldn't. It would be in front of the log or the ln. Okay? Just like if it was an exponential function and there was a negative in front of the parentheses, like, for example, 2, it would be in front of the 5. It wouldn't be in front of the, it wouldn't be 5 minus the 1/3.
Yeah.
It would be negative 5 times. Okay? If we look at this page for number 3, we have f of x is equal to 2/3 times 3 to the power of negative 2x. Is this an exponential function or a log function? Exponential. Perfect. Your domain automatically is what? So from negative infinity to positive infinity. To find your range, you need your horizontal asymptote. Your horizontal asymptote comes from your vertical shift. Do you have a number after this 3 to the power of negative 2x that's being added or subtracted to this? No. So treat it as plus 0. If you treat it as plus 0, what is your horizontal asymptote? Y is equal to 0. So your range is going to include the 0, and it's going to go to either positive infinity or negative infinity.
Positive.
Why does it go to positive? Because there's nothing happening. There's no reflections happening here. So automatically, your line looks like this. There's no negatives here other than the 2x. That negative 2 that's in your power has no bearing on your reflections. So it is what it is. It's going to positive infinity. So that means that our range is from 0 to positive infinity. Lastly, find your y-intercept. Rewrite this as y is equal to 2 over 3 times 3 to the power of negative 2 times 0. Negative 2 times 0 is 0. So that's 2/3 times 3 to the power of 0. Anything to the power of 0 is 1. So that's 2/3 times 1, which just gives you y is equal to 2/3. So the ordered pair that is your y-intercept is 0, 2/3. For number 6, you have g of x is equal to log of negative 5x plus 9. You have a what kind of function here? Log function. So automatically your range is all real numbers. So from negative infinity to positive infinity. From here, to find your vertical asymptote, take the part that's in the parentheses, set it equal to 0, and solve. So that's the negative 5x plus 9 is equal to 0. Move your 9 over, subtract it from both sides. That gives you negative 5x is equal to negative 9. Then divide each side by the negative 5, and you get that x is equal to 9/5. So your vertical asymptote is x is equal to 9/5. Now, your domain is going to have the 9/5 in it. Whether it goes to positive infinity or comes from negative infinity, you got to figure out. Look at the parentheses. You have a negative in front of the 5. Because that negative is in front of the 5, this flips. So automatically, from the very top of your notes for this, it told you that the log function looks like this. If you were to flip that horizontally, side by side, because it's inside the parentheses, it turns into this. So, for your domain, side to side, is it going to positive infinity to the left? Or sorry, positive infinity to the right, or negative infinity to the left?
Negative infinity to the left.
To the left. So your lowest number is going to be negative infinity. The highest is going to be from your vertical asymptote, which is 9/5.